Imagine the entire universe squeezed into a space smaller than an atom. That's the Big Bang. About 13.8 billion years ago, this tiny point was unbelievably hot and dense. Suddenly, it exploded. This wasn't an explosion in space, but of space itself. The Big Bang wasn't like a bomb going off. Instead, imagine a balloon with dots on it. As you blow up the balloon, the dots move farther apart, just like galaxies in our expanding universe. The Big Bang is still happening today as the universe keeps expanding. In the first fraction of a second after the Big Bang, the universe was incredibly hot and dense. It expanded rapidly and cooled down. Think of it like baking a cake. As the cake bakes, it expands and the temperature inside cools. As the universe expanded, it went through different phases, like ice turning into water and then steam. These phases determined how matter behaved and interacted. This rapid expansion is still going on today, stretching the very fabric of space and time. In the first few minutes, the universe cooled enough for protons and neutrons to combine. These formed the first atoms, mostly hydrogen and helium, the simplest elements. These atoms were like tiny seeds scattered across the universe. It took about 380,000 years for the universe to cool enough for atoms to hold onto electrons. This created a neutral universe, no longer a hot soup of particles. This era marked a crucial transition in the universe's evolution. Section 4, the Cosmic Dark Ages, when the universe went dark. After the initial burst of light from the Big Bang, the universe entered a period known as the Dark Ages. This era was a time of profound silence and darkness stretching across millions of years. No stars or galaxies lit up the darkness. The universe was a vast, empty void, devoid of the brilliant celestial bodies we see today. It was a time of waiting, with matter slowly clumping together under gravity. The forces of nature were at work, pulling particles together in a delicate dance. Imagine a vast, dark room with tiny dust particles floating around. These particles, though seemingly insignificant, held the potential to create something magnificent. Over time, these particles clumped together, forming larger and larger clouds. The process was slow and gradual, but it was the beginning of something extraordinary. These clouds of mostly hydrogen and helium gas would eventually become the birthplaces of the first stars. The universe was on the brink of a transformation, ready to burst into light once more. Section 5. Let there be light, stars and galaxies ignite. Gravity pulled together the giant clouds of gas. As they collapsed, they heated up significantly. Eventually, the cores of these clouds became so hot and dense that nuclear fusion began. The first stars ignited, flooding the universe with brilliant light. These early stars were massive and short-lived, ending their lives in spectacular supernova explosions. These explosions scattered heavier elements, the building blocks of planets and life across the cosmos. Section 6, our cosmic address, Earth and the emergence of life. Over billions of years, stars formed and died, creating galaxies like our own Milky Way. These cosmic events were not random, they were part of a grand cycle of birth, death, and rebirth. Each supernova explosion scattered elements across the cosmos, seeding the universe with the building blocks of life. Within these galaxies, new stars formed from the remnants of older stars, inheriting the elements forged in their fiery cores. These elements included carbon, oxygen, and iron, essential ingredients for life as we know it. The cycle of stellar life and death continued, enriching the interstellar medium with more complex elements. Around one such star, our Sun, a disk of gas and dust swirled. This protoplanetary disk was a chaotic environment, with particles colliding and sticking together. Over millions of years, these collisions led to the formation of larger bodies, eventually giving rise to planets. Over time, this material clumped together to form the planets, including our own Earth. Our planet began as a molten mass, gradually cooling and solidifying. Volcanic activity, asteroid impacts, and the presence of water shaped its surface. On our planet, conditions were just right for life to emerge, evolve, and diversify over billions of years. The presence of liquid water, a stable climate, and a protective atmosphere created a nurturing environment. From simple single-celled organisms to complex multicellular life, Earth became a cradle for an incredible diversity of life forms. Section 7, Our Place in the Cosmos. Reflections on 13.8 billion years. The Big Bang story isn't just about the distant past, it's about our place in the grand scheme of things. It marks the beginning of everything we know. From the smallest particles to the largest galaxies, this monumental event set the stage for the universe to unfold in all its complexity and beauty. We are made of star stuff, the remnants of ancient stars scattered across the universe. These stars lived, died, and exploded, spreading their elements far and wide. Over billions of years, these elements came together to form new stars, planets, and eventually life itself. We are a product of billions of years of cosmic evolution. From the formation of the first atoms to the birth of galaxies, every step in this journey has led to the creation of the world we inhabit today. Our very existence is a testament to the intricate processes that have shaped the cosmos. Understanding the Big Bang helps us appreciate the vastness of time and space. It gives us a sense of perspective, showing us just how small we are in the grand scale of the universe. Yet it also highlights the incredible journey that has brought us here. It reminds us that we are part of something much greater than ourselves. The night sky, filled with countless stars and galaxies, is a constant reminder of the universe's grandeur and our place within it. Each star we see is a beacon of the past, a glimpse into the history of the cosmos. The universe has been evolving for 13.8 billion years, and we are just beginning to unravel its mysteries. With each discovery, we gain a deeper understanding of the forces that have shaped our existence and the potential for what lies ahead. Our journey of exploration is far from over, and the cosmos still holds many secrets waiting to be uncovered.